In this video, we will be continuing on the beginner's guide to SDL2 in the Go language. So if you're just starting out in this video, you'll need to go to github.com, programming rainbow, beginner's guide to SDL2 in Go, and you'll need to clone that repository, move inside the directory, and you can take the source code that's in the video 1 folder right here, source code from video 1, and you can copy this main.go and you can move it in the top level directory. And you will be where we are for this video, where we left off in video 1. So I'd just like to show where we left off real quick. I'm going to go clean. I don't want that binary. Go run main. Yep. This is going to open a window. The window has a title, open window. And after 5 seconds, it's going to close. So if you try to close this window before the window close, you may get, depending on your operating system, it may say that the application is no longer responding, but it will still close at the end of 5 seconds. That's because your operating system knows that you've requested the window to close, but it's not closing. It's ignoring that request because we are not checking for those requests yet. Those are events and we're not checking those yet. So when you go to close it and then the operating system sees that the window is not closing the way you asked, it says that this application is not responding, thinking that something went wrong. But really, we're just telling it to close after 5 seconds. So in this video, we will be creating a proper game loop, and we will be checking events to see if those events are closed, and then we will be closing them. And I'm still unsure if this is happening across all Go, or if this is implementation specific, but print and print line on my system are actually set to standard error. Now, I cannot ascertain if that is actually Go for every operating system and every version, because when I looked around, I only saw this mentioned once or twice, and when I asked the AI about it, they said that this is not defined behavior. So I'm just going to show you what I'm talking about. Because of this, I'm going to I want this window to open and close immediately because I just want the message. So I'm just going to comment this 5 second thing out. Okay. And we will just put a message in here that we want to happen. So I want to put one of these standard error messages. Print F. And this one would be OS std error. So I'm telling it where I want it to go to, the standard error. And then we'll say standard, right? This is going to standard error. Let's put a new line. I don't know if this does a new line character. Okay, so print line. We'll say standard out. Okay, so one of these should be printing to standard error, this one because we're asking it specifically to, and you would think that print line is going to standard out. And again, I did not see specifically if this is guaranteed behavior for Go. It could be going to standard error or standard out depending on what system you're on. So I just want to show what this is happening and why this is happening. So I'm basically printing 2 messages. Okay, I got standard error, standard out. Okay, so I should be able to redirect one of these to dev null. Okay, dev null is the null device. It's like a black hole. I can just send anything there and it just disappears. It goes nowhere. Okay, so if I redirect 1, so we have 0, 1, and 2. So 0 is standard in. That's my keyboard when I'm typing. That's standard in is 0. Standard out is 1, which is the terminal and just general messages. And then 2 is standard error, which also can be the terminal. It doesn't have to be the terminal, but it is where the error output goes. So 1 is standard out. So I'm telling standard out to go to dev null. I'm redirecting standard out to dev null. That means it should disappear. I should get nothing. That anything that's sent to standard out should disappear. Anything sent to standard error should still be shown. Okay, but they're both still shown. And then if I redirect standard error, not standard out, but standard error to dev null, now we should see anything that's standard out, but not standard error. And I see nothing. That tells me both of them are actually standard error. And that's strange. That shouldn't be, but let's do another one here. Instead of print line, why don't we use the format? I think we can do this right here. Okay, so I just changed it to the format print line. Let's see what that does. And let's do the 1 again. Okay, so we've redirected standard out to dev null, and we got standard error. Now if we redirect standard error, we have standard out. Okay, and we can redirect them both by doing this. This is backwards. This is the one that I always forget. I think it's like this. Yeah. This says this is redirecting 1 to the null device, and this is redirecting 2 to be also be 1. So it's saying, hey, I want you to redirect all standard error to standard output, but also I want you to redirect standard output to dev null. So that gets rid of everything. So you might use this if you're, say, capturing logs. If you're capturing errors from programs, you could redirect your standard error to a file to print all your errors to a file, say if you're writing a game or something. So you want a difference. There is a difference between standard error and standard out. And so I am making sure, so the other behavior is, to me, not defined. So I'm making sure that I am printing this to standard error, which should be the way you're doing it. I am still unsure about the whole why print line is different than format print line. But I've only seen it asked, like on Google when I was looking this up, I only saw it mentioned on like one site where somebody was just asking that question. And when I asked the AI, it kept arguing and telling me, no, in fact, print line actually outputs to standard out. And then it was saying, well, it's not defined. It could do whatever. So I don't know the answer to this, but anyway, for sure, this is outputting to standard error. So that's where I'm trying to output, and that's what I'm doing. So that was in the last video. I just wanted to clear that up. Okay, so let's go look at our events. So basically what we want to do is we want to check events. And if you've asked the window to close, if you've clicked on the X mark or pressed Control-Alt F4, I think in Windows, or whatever your system is, if you ask the window to close, that's actually an event that happens. And we need to check if that close event was, happened, and then to shut the window down if it did, or shut SDL down. So the way we get, so it's an event. It's a type event, and this is going to be a strange one. So what it is the SDL event is actually a union. Do I have it open here? So let's open this up real quick. There's a little bit of a rabbit hole. So a union is a bit of memory that can hold a different amount. It can hold different items, but it only holds one item at a time. So it can hold however many items you define. It's kind of like a struct where you define different members, but the struct holds all the members you define. Whereas a union, when you defined a whole bunch that look like members, it only holds ever one of them at a time. So the entire size of the union is only as big as the biggest item that you define that it can hold. It only needs to hold one item. So whatever the biggest item is, it's going to be at least that size. And then basically what it is for this purpose is this union is basically holding a struct, but they could be all different types of structs, and they can have different amounts of information in them. And so you need to know what type it is. So all of the structs that are implemented into this union, the very first member of that struct is a type. So you can ask it what type it is, and then you say, now I know what type it is. I can look for the members of this type. And I can find more information, like what key was pressed, what kind of event happened, did the mouse move, was the button clicked? So in SDL2 and C, this is called a union, and the events are unions. So Go doesn't have unions, but the closest thing they can do is what's called an interface. So they're implementing this idea of this union as their interface. So it is a bit confusing. So just know that this SDL event is basically it's a small container that can hold one item that we don't know. It's kind of like you have a garage at your house, right? Say you own a house and that house has a garage, and it has a one car garage. But you have different cars. Maybe your friend has a truck, and you have a car, and your partner has a motorcycle or something like that, right? Your garage is big enough to hold just one of them, but it needs to be big enough to hold the biggest one. So if your friend has a truck, it needs to be big enough to hold the truck, but you can't put your truck in it and your car at the same time. It only holds one item. Okay, so imagine when you put your vehicle in the garage, you also have another, say a sign that's in the window of the garage that says what type of thing is in it. A truck is in this garage. Okay, I know a truck is in there. It must be my friend has parked the truck in the garage or something like that. So that's what this union is. It's a container. It holds one item at a time, but it can hold different items that were defined, but only one of them. So it needs to be big enough to hold the biggest one. It's not like a struct. A struct, if you put 100 different members on it, it's going to be the size of all 100 of those members, whereas a union only needs to be the size of the biggest one that it can hold. And so you always need to find out what the thing is it's holding before you can, if it's a truck in your garage, you're not going to go get the keys to your car. You need the keys to the truck. So you need to know what's in the garage, to use the thing in it. So if your event is a quit event, you can't get the member associated with a keyboard event to find out what key was pressed, because that's not even going to exist. It's going to be a quit event. So you need to know what type of event before you can find out what to do with that. So anyway, in Go, it's an interface, and it sort of acts like this union thing. In C, it's a union, and we're going to be looking for two different things in here. We're going to be looking for a quit event and a keyboard event, and it is done slightly differently. The quit event is it's just quit, SDL quit. But again, it's going to look a little different in Go. I'm just showing you what there are. And then there's a keyboard event, but we can actually check if it's a key down. Right here, SDL key down. So let's look at the Go one. The Go one, I don't think describes it very well, but yeah, so that's what's going on. So we have this event, and what it is every time we go through our game loop, there could be 10 events that happened since the last time we went through the game loop. You could have asked the window to close. You could have moved your mouse. You could have clicked your mouse. You could have touched a key on the keyboard. Your battery percentage could have gone down by 1%. Who knows? There could be all kinds of different events that happened. And so you have this queue of events. And we need to run through the queue one at a time, grab one event, check what it is, keep going through this whole queue of events. So we're going to do a for loop on it. We're going to run through the events. We're going to get the type of the event. And if it's a quit event, we're going to shut down. We also want to check if it's a keyboard event. If it's a keyboard event, we want to check, was the key pressed down or up? Is it a down event or an up event? Because otherwise we get two events happening. You'll get it on the down and the up. We just want one of them. And then we can go drill down and find out which key was pressed. But we can only do that which key was pressed if we know, in fact, it was a keyboard event. If it was a quit event, we're not going to do that. So that's why it's very important that we know what type of thing it is. So let's kind of start working through this. What we're going to do is this is going to be in the game loop. So right here is the game loop. Okay, so this right now is just happening one time. We clear, we present, we just wait 5 seconds. What we need to do is we just make this a loop. So I'm going to go for true. That sounds like a nice forever loop. And I'm going to tab these in. Okay, that's going to give us a loop that loops just forever. The problem with this loop is that each one of our cycles through this loop is lasting 5 seconds. And we don't want that. we want our loop to happen at about 60 times a second. So if we took, this is in milliseconds here. So if we take, we got to take 1,000 milliseconds and we divide it by 60. So we can find out how many milliseconds one frame should be if there's 60 frames in a second. So if we take 1,000, we divide it by 60, we end up with 16 2/3. So we end up with 16.6666, forever. It's not a really big deal. We can't put a floating point into delay, even if we, well, I don't think it'll error if we do, but it actually doesn't take a floating point. Let's look at it just takes a uint 32, I think. Yeah, it takes an unsigned 32-bit int. So if we put in a float anyway, it's going to be turned into an int. I'm not sure if it errors or not. We're not going to do that. Also, it doesn't really matter because there is a certain amount of time that happens for clearing and presenting. So we're going to be close enough. It's not really important in this thing. We're going to get about 60 frames a second, which is good enough. So we're going to switch this to 16 from 5,000, and that will make this loop happen 60 times a second roughly. But what we want to do now is start checking for our events. So we're going to make a loop that basically gets one event out of our event queue each time. And we're doing that with this function right here, which is called pull events. Pull events returns one event from our event queue. And it'll keep returning it until we get nil, until that is empty. So however many events occurred since the last time we did this. So say we go through, say there was one event on here and it was that you press the space bar. Yeah. That means nothing to us. We go through, we check that event, it's gone now. Now we clear the render, we present, some other keys were pressed, the mouse was moved, all this stuff. The delay happens. When we come up here, whatever those keys were pressed in the mouse movement is all going to be waiting for us as our new event queue. So that's what's happening. So it's like the queue that we pop through them, they get popped off the queue. And then when we're all done, it goes through the rest. And then whatever is in the new queue is up there for us. So for event, so we're going to get an event out of this each time. And we're going to use SDL pull. It's that one up there. This one right here. But it's not this get type. So we're going to get one of those events. And we want to keep doing it until event is null or nil. We're initially getting the event. We're going to continue to do it. And what we're going to continue to do is get more events. Okay, so that is going to be our pulling the events loop. So basically we're initially getting an event and we're going to keep getting the events until the event is nil. Okay, now we're going to use a switch statement here, but we're switching on this type of the event. Okay, so in a switch statement, we can't do this outside of a switch statement, but in a switch statement, we can get the type of this interface. So this interface can be multiple different types. We can get the type out of it just by using a kind of a type method on it. But it only works in a switch statement. And we actually want the value of the event. See, we don't know what it is, right? It could be many different things. It's like that union. It could be a quit, it could be a keyboard event. We don't know what it is. So what this is going to do is it's going to let us switch on the type of it, but it's also going to return the value of it so that we can drill down into whatever it is. We can get that specific key that was pressed. So we're going to get the value of it in E. We don't know what type it is, so it's got to do it itself. And here is how we get and this only works in a switch statement. We can put type here. I've been like this, yeah. So basically we're switching on the type, but we also have the E that we can use in a minute here. But the important things is this, the type we're looking for is the quit event or the keyboard event. So those are here. Let's see. Here's the quit. So it's a type quit, and it's this It's the interface for the quit. It's satisfying the event interface. So this is one that we're looking for, just the type, and the other one is the keyboard event. The keyboard event, we can drill down into it. We'll talk about that in a minute, but let's just do the quit one first. So this is an easy one. We're just checking the type of it. So we're going to say case quit event, and if this happens, we're just going to return. So if we return off this, we're just returning at a run. And what happens when we return at a run? Well, we're done with the program, and all these defers pop up and clean up after themselves. So all we do is simply need to return from here. Okay, so I'm just going to give it a little space there. Used. Yeah, since I'm not using E yet, I'm just going to remove it. We will use it in a minute here. Let's just see if when we ask the window to close, if it closes for us now. I'm going to remove that. Okay, so I'm going to tell the window to close, and there we go. I'll do it real quick there, and we can leave it open for a number of seconds. Time went by, and I'll tell it to close, and it's working perfectly. But what I want to do is also tell it to close when I press escape. So let's try that. I'm pressing escape and nothing's happening. Pressing space, pressing other keys, nothing's happening. And I tell it to close. I don't have an X. I'm using a tiling window manager, so I use a keyboard shortcut to tell things to close, but that's normal for my system. What's normal for your system to use either a keyboard or pressing a red dot or an X, whatever is the normal for your system is what you would use. So now we've checked the quit event. So now let's add a keyboard check. So the keyboard event. So now with the keyboard event, we want to know specifically what keyboard event happened. Like it runs into the other problem. See, the way that this would happen in C is I wouldn't do it like this. I would check the type. It's different. Sorry, it's very confusing here. But the C thing, I would be checking this against a constant. But since this is an interface, I'm already checking this type thing. But this type right here, this keyboard event, is not telling me if the keyboard is being pressed down or being let go and pressed up. That's actually, whenever you press a key, two events happen. The key goes down, and then it goes back up again. So it's one event for down and one event for up, and we don't know which event that was. So we need to find out. So since we were pulling E out here, when we pull E out, we can actually check the type of this. Let's see, I think I have it in here. So we have this type. So on the keyboard event, we have a type. Okay. So we can actually check if this is a key down or a key up. So I want it to only be a key down. So I want the event to happen when the key gets pressed, not when it's released. So I'm just going to use an if statement on this. I'm going to say if E, and we're going for type, equals SDL, and this is all capitals, key down. So that's if the key down happened. Now, if it did happen, I want to run a switch statement on which key was pressed. So this is going to be a switch on E. Now, I'm going to show you what I'm switching on here. So we use this type right here, right? But down here is represents keys that was pressed or released. So I want to look at this key sim, which I have opened here. This key sim has scan codes in it. If I open the scan code here, well, it redirects me to the SDL webpage. So here's the SDL webpage with the actual scan codes. So SDL scan code and then whatever key you want. And I want the SDL scan code escape. It's one of them. It just says escape. So basically what I want to switch on is, where is it? Back here. So we know that E has type, but E also has key sim. And key sim has another member called scan code. And then we know what the scan codes are. So that's what I'm going to be switching on. I'm switching on E and then key sim. Yeah. Key sim and then scan code. So that's what we're switching on there. And now I can check specifically which keys were pressed. So I can do a case, and we'll have other keys later, that's why. So case, and then this will be SDL. I can do K escape or scan A, it doesn't matter. I think I can just do K escape like this. But I can do it two ways. Let's look at this again, the scan codes. Yeah, that's what it is. I know what's happening here. Okay. Yeah, it's right here. They're just taking the SDL part off. So we could use this here or this SDL scan code, either way. So it would be either this or we could do scan code. The SDL is removed. Either one of those should work. It doesn't really matter. But if that was pressed, we want to do the same thing. We want to return. Okay, so I'm going to try that. And then this time, if I press escape, I should get it. It should close on me. Okay, so I'm going to press escape now. I'll try that again. And now. I'll press spacebar, press G, D, A, escape. Okay, so it's definitely getting the escape, and then I'll check the normal closing method, and that works too. Okay, so that, I know that's a bit weird to set up here, but basically now we have this loop that's constantly happening. This is our game loop. And we're checking the types, the quit. We don't really want to know that much about it. We just know that something was requesting that this program be quit. So we're going to let that happen. And now we can also check the keyboard as well. So I know it's a bit weird. We have this extra thing here where we're checking if it's a key down event. We want to know it's a key. Otherwise, later on, we're going to have things happen twice when they shouldn't. But anyway, key down event, and then we're checking which key was pressed. This E key sim scan code, and if that was the scan code escape or K escape, we want to return. And now we can simply just add a different case for other keys and then have them do something else. So that's how we set up a game loop. So we didn't change anything else in the code. I know this kind of unions is a bit complicated and interfaces. It's a little bit confusing. But yeah, basically these events, it's basically has a queue of whatever, all these events that happen. In each of the events, they could be a number of different things, and you have to find out what that thing is first before you can get more information about it. So it's just popping one event off at a time until the events are empty, and then we're checking the type. We're dealing with the type. And if we know it's a keyboard event, we're checking if it's a key down that happened, and then which key specifically. Okay, so that is how you close a window. Let's go up here and change this to close window. That's how you close a window in SDL2 and Go. And also we have a game loop set up now. So this is happening at roughly 60 times a second now. And I hope I explained why I was doing this printf OS standard error, sorry. That's because I always want to make sure that my message is being sent to standard error. At least if there are error messages. Okay, so that's going to be it for this one. I hope you enjoyed that. I hope it was educational or entertaining, and thanks again for watching. Bye.